Welcome! Have you ever wondered how scientists figure out what the atmosphere of ancient Earth, or even other planets, was like millions of years ago? The answer lies in something unexpected: volcanic glass. Volcanic glass, also known as obsidian, is essentially magma that cooled so rapidly that mineral crystals didn't have time to form. This rapid cooling often happens when lava or magma is quickly quenched, such as when it erupts into water or air, locking in its chemical composition at that moment. What makes ancient volcanic glass special is its incredible preservation ability. Because it lacks a crystalline structure, it's highly resistant to chemical alteration, protecting what's trapped inside for eons. The real secret to unlocking atmospheric history, however, isn't the glass itself, but tiny bubbles trapped within it, ancient gases. Magma naturally contains dissolved gases. When a volcanic eruption occurs and the lava cools almost instantly into glass, those dissolved gases don't have time to fully escape and form bubbles, thus becoming encapsulated within the solid glass matrix. This makes volcanic glass a geological time capsule. The gases inside represent a pristine sample of the atmosphere that was present during the eruption, locked away from contamination or change. By analyzing these tiny gas bubbles, scientists can reconstruct the atmospheric conditions of the past, offering crucial clues about how early planetary atmospheres formed and evolved. Scientists use highly sensitive instruments to measure the composition and ratio of these trapped gases, including elements like water vapor, carbon dioxide, and nitrogen. The data extracted allows researchers to determine the relative abundance of atmospheric components from millions or even billions of years ago. Let's look at Earth. Terrestrial volcanic glass has been vital in understanding our planet's own atmospheric journey. Samples of deep-sea volcanic glass have offered direct evidence of the volatile composition that contributed to the development of our early atmosphere and oceans. These ancient compositions are dramatically different from our modern atmosphere, highlighting the profound evolutionary changes our planet has undergone over geological time, especially with the rise of oxygen. The insights gained from Earth are paving the way for exciting research in broader planetary science. Scientists are eager to apply these same analytical techniques to extraterrestrial volcanic glass, particularly from samples brought back from the Moon, Mars, or potentially Venus. Understanding ancient atmospheric composition is key to determining the past habitability of other worlds and predicting the potential for life beyond Earth. In conclusion, volcanic glass proves to be an indispensable tool for planetary scientists. It offers a direct, unspoiled record of atmospheric components that have long since vanished or been altered, safeguarding billions of years of planetary history. The search continues for these tiny time capsules on Earth and other planets, promising to deepen our understanding of how atmospheres and life came to be.